Hi. So today we're gonna talk about Gamal encryption. So let's say P is a prime. Okay. So as you already know, ZP star, which is set of all co-prime numbers up to P, co-prime to P, is a group of order P minus 1 under multiplication. Okay, multiplication mod P. So now what we do is the following. We choose a number X, which is a number in ZP star. This thing has 1 2 3 up to P minus 1, and this X must be less than P minus 1. Why, you'll get to see soon. And what we do is the following. G, as we know that this is a cyclic group, so this is generator, so we consider G power X. Okay, X is a secret. Okay, we consider G power X, and we will denote this thing by Y. Everything mod P. Okay, or in other words, everything is happening in ZP star. Okay, so now what we are going to do, we will publish these numbers. Okay, this is a public key. So say Alice wants to send out a message to Bob, so Bob will do all this construction. Okay, this whole construction will be done by Bob. Okay, everything Bob will do is constructed by Bob. Excellent. Now what Alice is going to do, Alice wants to send out a message to Bob. So she is going to use this key. Okay, say Alice wants to send a message M. Okay, where M must be an element of ZP. Okay, yeah, ZP is 0 1 2 3 up to P minus 1. Yeah, M doesn't need to be co-prime to P. Good. So what she will do, she will do the following. Okay, she will construct two ciphertext C1, which is going to be G power Y, where Y is randomly chosen by her. Oh, I cannot use Y, I have already used. So let's say she choose a random number K. Okay, K in 1 2 3 up to P minus 1 to P minus 2, sorry. Good. After choosing, she will raise G to K and she will get C1 and C2. Also she will compute C2. What is C2? A message times the Y which was published. You see, this is Y which was published, so Y to the power K. And see, nobody knows K and nobody knows X because discrete log problem is difficult. Okay, so we are doing all this thing modulo difficulty of discrete log problem. If it was easy to solve, then everything is broken. Yeah, which you might anyway know. Good. So now this is the ciphertext. C1 C2 is a ciphertext which will be sent through public channel. So if anybody intercepts, this is encryption of M. So anybody intercepts cannot figure out what the message M is. So now this is, we'll go to Bob, and Bob needs to decrypt this thing. So Bob is going to decrypt this thing. Let's see. So what once he receives this ciphertext, what Bob is going to do is the following. See, Bob, Bob has this X secret with a Bob. Now Bob is going to do the following. He has C1, he is going to raise it to X. Yeah, not P. So he has this number C1. And now let us denote this thing by, let's say, S. Now here he has this number, okay. Now what he is going to do is going to calculate the inverse of it, which he can do, yeah, modulo B, yeah, using Euclidean algorithm. And then he already has C2 also, does this thing. But if you observe, what was C2? C2 is this thing, yeah, from which we can see that M y to the k. But what was y? Y was g to the x. Yeah. So this is g to the x to the k. G to the xk. Yeah. And if you see c1 to the x, what is c1 to the x? C1 is g power k. G power kx. Kx is same as g power kx. G power kx. G power kx is same as g power xk. So if I take inverse, so the inverse, yeah, okay, for some reason bracket is not working. I don't know why. Yeah, but you understand what I mean to say. Okay, so this will cancel out, and what I get is m, and hence we have a message I'm recovered. So Bob knows the message now. So this was Gamal encryption. I hope you enjoyed. Thanks very much.